Good evening to everyone present here. Today's topic is BIM for structural design and detailing. First of all, I will introduce my company. We BIM Labs Engineering Services Private Limited, situated in Kerala, southern state of India. Our head office is located at Karakotam in Trivandrum. Our another branch is located at Cochin. We have three franchisees. One is in Karamana, that also in Trivandrum. Others are at Calicut and Kottarakara. BIMLabs is an Autodesk learning partner and authorized training center also, and a member of Indian Green Building Council. Our services include BIM training for students and corporates, BIM implementation supports for corporates and organizations, BIM project outsourcing, BIM placement service. We have three main divisions. First one is BIM Finishing School, which is our training division, and the project division is called BIM Studio. Is our placement service. You can contact us through mail, WhatsApp, Facebook. Info@bimlabs.in is our official mail ID. And we have two YouTube channels, bimlabs.in and Bzigntalk. We upload BIM related videos and tutorials regularly. Please like and subscribe. Meet the presenter. I am Lima Manohar, graduate in civil engineering, and I am the senior technical engineer of BIM Labs Engineering Services Private Limited. I am a certified instructor and a certified professional in AutoCAD and Revit architecture. Lima at bimlabs.in is my official mail ID. For further queries, you can contact me through this mail. Agenda for this today's topic is structural BIM objectives, different method of structural detailing using BIM, interoperability of different BIM tools, visualization of rebars. BIM for structural design and detailing. BIM is an intelligent 3D model based process that helps structural professionals to design, detail, document, and fabricate structural systems. BIM enables project teams to work more collaboratively, helping to optimize design to improve accuracy and connect to fabrication. BIM in structural engineering can reduce the number of requests for information, that is RFI, from the contractors and also provide all the stakeholders with the opportunity to explore various readily available alternative design scenarios. Moreover, a rich data model allows engineers to address competing design parameters, quickly test the validity of and the structural integrity of different options easily in the design phase and easily adjust the structural model based on the design changes. The main objective of the session is evaluating the concept of BIM, its uses and benefits, particularly with the respect to the structural design and detailing, establishing a standardized template for structural design using BIM tool. Coming to the heart of the today's session, there are different methods for achieving the structural design and detail. The method one is if you have a structural plan and a layout drawn in AutoCAD or its PDF, you can directly import that into a BIM authorizing tool. Here, Revit. Revit allows structural engineers to create their model and document in advanced BIM environment. By using Revit, structural designers and engineers can produce accurate design intent models and give engineers and detailers the information they need to develop the model to a higher level of fidelity. higher level of fidelity for fabrication and installation process. In another method, you can directly model the structural components in Revit structure and complete the model. And the analytical model is exported to the ATABS or STAD for analysis and design. After the analysis and design, from the design data, you can create the detailed model in Revit and allow you to create accurate documentation like shop drawings, as-built drawings, all that, and estimations like bar bending schedules. Importing the plan from AutoCAD. This is a two-story building of a shop, and the structural engineer created different layouts like column layout, plinth beam layout, footing, pile layouts, and slab layout. All the structural layouts are created, and you can import any one of the structural layout which gives a maximum information to the Revit. By the reference of the imported layout, you can model in a Revit itself. If you are using the PDF, then Revit 2020, you need to take the Revit 2020 because the PDF option comes in Revit 2020. So you can directly import the PDF also. Here, this is a images of the importing platform. You can directly take in the insert tab. You can import the CAD file or you can link the CAD file. Choosing the this option, only few more settings are there. The main settings are the levels and the imported unit and the positioning. You can default settings are auto detect. Unit is auto detect. You can change the importing unit. You can change and the positioning where the layout imported plan to came into the Revit. Okay. For creating the structural model, you need to model columns, beams, slabs, etc. For creating a column, first of all, starting with creating a structural model, first of all, you need to create the grid lines, levels already there. So grid lines, you need to create the grid lines. Then you can take a column from a structural tab. There are vertical column, you can create as a slanted column. And default column is a I section of a steel material. You can load it the concrete, any other material, concrete, timber, any other material or any other sections can be loaded from the load family, and its dimension can be changed from the edit type also. And the columns heights can be set directly from the option bar, or if you placed the columns, then finally you can select the column and can change the possibility of changing the base level and the top level. And the grid option is a easy tool which model the columns at the intersections of each grid lines. And for the beams, it's also taken from the structural. Default is a universal beam of steel material. You can also take another material or another sections from the load family itself, and you can draw straight beams or curvical beam, or on grid option is also there for placing easily. You can place the beams in the grid up by a single click. Okay, these are the images. For slabs, mainly you can go with the two methods. If you are considering the one-way, two-way slab or like this, you can take the floor option in the structural tab. Otherwise, you can take its model is as a slab itself, providing the material and the thickness, and draw like a floor. The boundary you can provide and the direction. Overall, the stage by stage the model completed finally like this, and the analytical model can be exported to another analysis tool. And Revit allows not only concrete structures, steel structures also. Revit 2019 introduced Revit Steel tab also. From here, you can model the what steel columns, bracings, purlins, any type of structures like a warehouse, a tower, trusses, anything can be modeled easily. Revit allows you parametric connections for more easily modeling, and simple detailing can be done. And in Revit you can document all the connections, all the elevation, all the views you can document, and the relevant tags are available inbuilt in the Revit. And for the further detailing, you can export this into a advanced steel. Advanced steel also a Autodesk software for the steel. There are so many softwares like Tekla. Tekla is a best steel detailing software, but it is very costly. Advanced Steel is Autodesk software, so you can fetch it for a 1 year license. So from the desktop app, we can download the Revit extension, Advanced Steel extension for Revit. And this plugin allows you to interoperable with the Revit Steel to Advanced Steel. While you are importing this to a advanced deal, you may be possible to change the models, material that is, and the connections also. You can change it in the advanced deal. And coming to the second method, this method allows you to import linking the architectural model into a structural template. In this method, if you have an architectural model, you can link the model into a structural template and can model the structural elements. This can be achieved by a copy monitoring method, which means that the Revit models the copied objects with the object it has been copied from. If the architect makes a change to something, that is monitored, and then a message will appear when the link is updated. Here, I created with a reference of the AutoCAD plan, a model, 3D model of that shop, and I just linked that into a structural template. Here I choose the structural analysis default metric. You can directly from link the Revit file from the insert tab itself. Revit is linked to a Revit file itself. And the copy monitoring. First step is copy monitoring all the relevant levels and grids. Copy monitoring option is for creating structural models. We not need to want the all the architectural datum elements like grids, levels, all that. So we can copy needed datum elements and monitor. Here, this is a picture representing the copy monitoring of levels. And you can also replace the architectural element into a structural element. For example, if a column is placed in an architectural model with architectural columns are placed, you can directly using the copy coordination settings or copy monitoring option, you can directly replace the architectural column into a structural element. Another example is an architectural toilets can be changed into a MEP related MEP plumbing system or MEP toilets, MEP option. And coming to the interoperability option or exporting to analysis software. Revit having free plugins available in the Autodesk App Store. First one is the export to ETABS option. After completing the model, you can export this to an analysis software, and this export to ETABS plugin is mainly known as NASA's tool, and this will export the Revit.rvt file into a .e2k format, and you can directly open from the file tab of the ETABS and can import the model. And the next is the CSI X Revit, which you can convert the ETABS file into an IFC format, that is Indian Foundation Class, and can import into a Revit. We have another possibility to exporting the Revit. This is robot structure analysis. This is an Autodesk plugin. Other software are ETABS is of CSI and STAD is of Bentley. So there is uh, not that much of easy to interoperable. But for the same company, robot structure analysis is a bidirectional workflow. It provides a bidirectional workflow, and it will be more easily, and we can model be transferred directly and updated directly and provide provisions for reinforcement checking is also available there. And next one is the exporting to StatPro. StatPro is a Bentley software for structural analysis and design. This is a Revit STAD ISM plugin, but the main drawback of this plugin is the Revit updates yearly, but the ISM for each year is not updated properly. That's the main drawback. Then coming to the third method, you can import. This is a reverse method. In this, you can what you can model or you can import the line sketches of the AutoCAD layout to the ETABS and can export it, convert this into a ETABS model, and again it can be exported to the Revit itself for the further detailing. After in ETABS you can analyze, design, all the things can be done, and for the further detailing you can again by using the CSIX Revit format you can export. I will explain it with the software. I will share my screen. This is an ETABS interface. Here I already modeled a small building. The main thing is in this is you can first of all you can create a grid line with a specification from the AutoCAD itself, grid to grid distance, or directly importing the line sketches also. And to create grid lines from the edit option itself, you got the grid lines. And first of all, you want to create a material specification for concrete and rebars. Then you need to create the sections, the framed section or slab sections, all that create and model. Modeling can be done by quick draw columns, quick draw beams, rectangular floors, draw floors, shear wall, all that you can simply model the columns and the beams. After modeling completed, you need to assign the loads. Loads can be assigned by joined, uh, frame loads, shell loads, all that. If you're choosing the framed loads, there are concentrated loads or UDL, UVL, all are possibly in this method. If I am choosing a frame load, you can directly provide the uniform load or varying load here also. If you are providing the varying load, provide the equivalent distance and the corresponding load here. And for uniform load, directly provide the load here. And there are three options. Add to an existing load. If you want to add an existing load, you can choose this. If you want to replace any of the load, you can do this. And if you want to delete anything, delete existing load. While selecting any beam or column and just right click, you got all the properties, geometry, assignments, loads, design, all the data can be seen. A modeling can be completed after you can analyze the model. You can, before analyzing this, you can check the model, and for finally, you going to run structural analysis. It will change the model to a deformed shape like this. From this option, this is display support spring reaction. You can individually taking the reactions of each load cases, dead load and live load, or for the combination of 1.5 of dead load plus live load, and the all the reactions and the bending moment in the different directions. Just apply and okay. And this option, display frame or pierce spandrel, this is mainly for looking the bending moment and the shear force. Here also, individual load cases can be applied or combination. Mainly, we are doing combination loads. And the moment 3 is the bending moment and the shear force, shear 2 is the shear force. And just moving like the cursor, you got each and every values. Or just selecting the beam or column, then right click. Here you can see the maximum and the minimum values you got. And for moment 3, here also the bending moment diagram you can see. And by simply right clicking this, here also you got the values of bending moments. After the analysis, the model will be locked. For the further modification, you need to unlock the model. And for design, here ETABS provide different designs: steel frame design, concrete design, composite beam design, composite and shear wall design, concrete slab design. Different designs are available here. And for the further modification, you need to unlock the model. And for design, here ETABS provide different designs: steel frame design, concrete design, composite beam design, composite and shear wall design, concrete slab design. Different designs are available here. Okay. First of all, starting with the ETABS, you can three settings are there. You can choose whether use saved default settings. ETABS having a default settings for all elements. So you can choose that one, or otherwise use settings from a model. Already, if you have an already done model, you can take the parameters from that. And this is the best method. Use built-in settings. Here we can change the display units, steel section database, steel design code, concrete design code, all that. And coming to the next page, you can provide the grid dimension, number of grids in X, number of grids in Y direction. If you want to customize any of the grids spacing, you can go into the custom grid spacing. Here, there are two methods. Display grid as an ordinate. In this method, from a datum, all the grid elements measurements are taken or input. The next one is the display grid as spacing. Here you are providing the grid, individual grid to grid dimension as providing. And the number of stories can be provided in the simple story data here. And if you want to edit the custom stories, you can choose this option. While importing the line sketch as a .dxf file from the AutoCAD, like it will be like this. After the line sketch, that's a sample line sketch. You need to create the grid lines for this and to model each and every components in the ETABS. Then this is the ETABS interface. After the loads analysis and the design, the model will provide this much of values. This is the area of reinforcement provided by ETABS. You need to manually calculate the number of rebars provided for each column beams. And after the design data, you can model into the structural detailing software, that is Revit structure. You can place the reinforcement. There is rebars for providing main reinforcement and the stirrups, and area reinforcement for detailing shear walls, floors, all that. And path reinforcement is mainly used for detailing the sunshades or path-based components. And this is a pictorial representation of a detailed column. Here, you can change from the rebar shape browser. There are a lot of rebar shapes are there. You can directly take which is you need, or otherwise you need to create or draw your own rebars, and can change the properties from the property palette as instance property, or going to the edit type, you can change the bar dia, hook length, and the bar ankle, or all the data can be changed from the edit type also. And the visual option is the, in the realistic option, you can provide the graphical display option little bit lower. You can see the reinforcements as like in the original, and for this the detail level should be a fine. Placing the area reinforcement. First of all, we provide an area, drawing an area and provide that major direction. And from the property palette itself, you can change the major rebars direction and the distribution bars details, the bar dia and the spacing and the stirrups details. All the details can be entered or changed from the property palette itself. And placing the reinforcement by path. In this, creating the reinforcement particularly to perpendicularly to the sketched path. And this also you can change the perpendicular angle of that path reinforcement in the property palette itself. Finally, we can document the model into a sheet. This is an Autodesk sheet. You can customize your own sheet and can place with a reinforcement detailed tag. And the section, you can take all the views into a sheet. Section, elevation, plan view, detail view, and for more detailing, you can take the call out views, and all the tags, the reinforcement tags can be applied. And for the documentation after this, estimation and scheduling can be done from the view tab itself. You can take the estimation of the rebar schedules, and while providing the images, you can create it as a bar bending schedule. And this data can be exported to an Excel, and it can be used in an Excel format also. This is the final output of that model. I will share my screen to the software itself. This is the model, Revit model, structural detailed model of that shop. Here, all the reinforcement you can see perfectly. And here I provide some filters for representing the rebars. That is the visualization option. Here, in the visualization option, you can provide filters for different diameters by providing some equations. And you can provide the line pattern and the hatch pattern and the transparency. All the details can be provided in the filter option for the visualization of the rebar. And finally, you can provide create this as a 3D model, 3D detailed model. And you can provide the line pattern and the hatch pattern and the transparency. All the details can be provided in the filter option for the visualization of the rebar. And finally, you can provide create this as a here model to be detailed model. Here I just placed some section, floor plan, and the call out of a column plan into a sheet. And I taken a rebar schedule, and you can provide some equations. By using this, I created the reinforcement weight and equation parameter like this. This is the floor plan, and this is the imported layout from the AutoCAD. And you can provide some equations. By using this, I created the reinforcement weight and equation parameter like this. This is the floor plan, and this is the imported layout from the AutoCAD. Okay, at last, finally, you can take any one of the method which is easily for you. I just take this as a standardized template from the AutoCAD. Just model the structural layouts, then structural model. Then from this Revit, I just exported to the ETABS, and again detailing can be done with the Revit. You can take any one of them. And for the feedback, the certification is Autodesk. Your participation certificate is Autodesk. So just fill structural model. Then from this Revit, I just exported to the data. And again, detailing can be done with the Revit. And for the feedback, the certification is Autodesk. I just uploaded the link to the chat box. Everyone, please respond. This is for your participation certificate. It is of Autodesk. I just shared the link to the chat box. And we are planning for a workshop of this BIM for structural design and detailing, 5-day duration of 3 hours each day, starting from 11th January 2021 to 15th January 2021. The fee is 3,500 per head. And next one is next to design talk. This is lean construction taken by took by some Bimla BT technical engineer. BIM community is our platform for connecting all the BIM users, professionals, students in one platform. Here we provide free trainings, seminars, design challenges, knowledge evaluation checks, etc. So by attending this BIM community questionnaires, you can score some credits. So you can redeem it for the future trainings also. And the main agenda for the BIM community is the learn, unlearn, and relearn. Our Facebook ID, I will share in the chat box, and the LinkedIn ID also. Next one is the WhatsApp. Please check. Telegram. And final one is the Google Classroom. All the links are shared in the chat box itself. Please check. And the feedback form, you must do the feedback for your certifications. Thank you all. If you have any queries, please ask. If you have any queries, please ask. Any slide want to repeat? Thank you all. Thank you.